Hello everyone, you are watching Civil.Pro. This is Mainak, and today we will do a G+6 building design using Tekla Structural Designer. So I had uploaded a video previously on G+6 building design, so you guys had liked that video, so I'm continuing this series. And in today's building, the unique thing will be that we will be making cantilever beams, cantilever portions, and there are some common earnings associated with the cantilever beams. How to make the plan such that there is no warning occurs, and why the warning occurs, all things we'll discuss. And also we'll discuss how to offset columns of different sizes in the Tekla Structural Designer. So everything we'll discuss. So let's get started. So the plan, you can just start take a screenshot of this apartment plan, and then we can practice along with me. I highly recommend you practice along with me so that you have some work experience. Okay, so let's get started. So first of all, this you can see this is the Tekla interface. We'll click on new to start the work here, and make sure you select your country codes and all the things from the settings here, and also from the model settings here. So you can change these settings if you want according to your country code. And after that, you go to model and then construction levels. To create your construction levels, you insert level below. It will be minus 1.95, which will include the plinth height and the foundation depth together. And this will be our SSL, because we are going to provide a slab at the plinth level as well for properly, so that it supports the parking space properly, because the ground floor is going to be stilt floor, or it is only to be used for parking. So we'll insert above particular floor here, and the spacing will give us 3 meters, and the slab thickness at the plinth level will give us 150 mm, and the slab thickness above will give 200 mm. So here we will do one more floor here, insert above here, and in this particular floor we will make this source as equal, we'll make it later, and insert above. So it is G+3, G+4, G+5, G+6. So G+6 building has been levels have been made, and click on OK. So once the levels have been made, make sure you save the file, because saving the file is important, otherwise you'll lose the important work. Okay, so give it a name and then save the file here. So after saving this particular file, we'll make the grid lines here. So with this particular, you can take a screenshot of this before practicing. Make sure you make the high resolution, take a screenshot of this particular plan, and let's get started. So previously we'll use the calculator to just calculate some things imagined in the grid lines. One change I'll do to column orientation is this column, I put it with this column here, and approximately we'll draw the grid lines of all this this complete plan here. So first of all, let us draw this grid line. So it is around 34 feet. So if you do 34 divided by 3.28, it comes around 10.36. So let's go 10.5, a grid line here. Let's take a straight grid line here and draw at the plinth level. Click F2. You click on escape. You should be 90 degrees only. So click F2 and then 10.5, and then move the mouse downwards, the downwards direction, and click on enter. Okay, so here, I think we had not drawn properly. Okay, so here just select downwards 10.5, take it downwards, and then click on enter. Okay, so now this is done, and now take this grid line once again. You can just take this parallel quick grid line. Okay, so using this parallel quick, next grid line is at 10 feet. So 10 feet is equals to 10 divided by 3.28. If you do, it comes around 3.05. So we'll take 3.05 for the next grid line here. So select this F2, 3.05, go in the right direction, click on enter. Okay, then click on escape here, and for the next grid line we have again 8 feet 9 inch. So 9 inch means 9 by 12, it means 0.75. So 8.75 divided by 3.28, it comes as 2.70. So 2.70 is this distance here from left click here, F2, 2.70. Delete with other things, 2 point. Make sure you give the point correctly, 2.70 here, enter. Okay, escape, and then the next point is at is this portion of this slip, and then this portion we have similar floors. So this portion will take 3 feet plus 3 feet 6 feet. 6 feet plus 5 feet is around 11 feet. Okay, 11 feet and 6 inches, and plus we'll add the wall width later. So 11 feet 6 inches means 11.5 divided by 3.28. and it comes around 3.51. So 3.51 plus two 10-inch walls means 0.25 into 2. It comes as 4.01. So let's take 4.01 here, from here to here, f2 4.01. Okay, so now this is almost similar, but in only this distance 9 inches 99 inches less. But let's take this 8 feet, 8 divided by 3.28, it comes as 2.44. so let's take 2.44 from here, select this f2, delete everything, 2.44, enter, and then escape, and then the last distance is the same. It is this distance is similar, so it is 10 feet, which was your 3.05. okay, so 3.05 you can see from here, this is 10 feet in this plan. So 3.05 from here, f2 3.05. okay, enter. And now take a normal grid line and join the top portion. So we'll take the offset from there, later we'll draw the cantilever also. okay, so here the first from the first grid line, you can see the distance here. So it is around 10 feet 8 inches plus this some distance here it is there. okay, so this particular for this particular line, so it is only 10 feet 8 inches. So I'll move the column here because this column is also here, so for similarity I'll move the column here. So 10 feet 8 inches, so we already know 8 divided by 12 is 0.67, so 10.67 divided by 3.28 comes as 3.25. so let's draw 3.25 here, select this, first of all do parallel quick, and then select this, and then f2 3.25, and move your cursor below the downward direction, enter, escape, and then the next distance will be then it will be small distance, rather 5 feet. okay, only, so 5 feet, so 5 divided by 3.28, it comes as 1.52. so okay, so here select this one, f2 1.52, move downward direction, enter, escape, and then the next distance is large, it is 10 feet 8 inches plus 5 feet, so it is 15 feet 8 inches. okay, so 15.67 divided by 3.28 comes as 4.78. so 4.78 is the final distance, f2 4.78, downward direction, enter. okay, let's see how we have a balcony at the front portion. Now balcony in the front portion, and size we have, the balcony is around, you can say whatever is looking okay. So yeah, this is the even balcony is 3 feet balcony. So around these two and this two we have the balcony, 3 feet balcony we have. okay, so let's go for the ground floor first, and later we'll see the balcony. And before that, there is also a portion here. So here you can either give the shear wall, or you can give columns at 4 ends and normal wall. So we can give column at 4 ends for this project. okay, so it is 3 feet from all the sides. So 3 feet means 3 divided by 3.28, 0.91. so we'll take parallel quick here. First of all, we will draw this grid here, f2 0.91, enter, and then escape, select this f2 0.91. okay, some problem occurred, so select this f2 0.91. okay, okay, and this particular distance here, it is around 4 feet 7 inches. So if we add this 4 feet 7 inches, 7 divided by 12, it's 0.58, and 4.58 divided by 3.28, it's around 1.39. let's take 1.4. so this distance is around 1.4 here, 1.4, escape, and then we'll add the columns here. So first of all, take the column here, column, normal column, We'll have two kinds of columns here. So first of all, here we go with since this is a large building, so at least M30 grade of concrete, and columns, first of all, here for this particular zone we'll go with columns of 300 into 300 for this lift portion. Okay, and this reinforcement of the column here will take as FE500, and this also FE500. Okay, and automatic alignment will turn the automatic alignment off, and here releases, in the releases this will be normal, and in the analysis and design control, so as per our IS code we have to take 70% moment of inertia for columns, so we'll assume 100%, 100 minus 70, which is 30%, as crack section. And for beams we have to take 35% moment of inertia for beams, so we'll take 65% here. And then we have the slenderness, and this is okay. Stiffness, so here drift check, we are going to give nominal power of 40, and take this in a seismic force resisting frame direction 1 and 2, because direction 1 and 2 is the two lateral directions. If you are designing about zone 3, then always give seismic moment resisting frame, not ordinary moment resisting frame. And then we save this file. So this will be C 300 cross 300, or just 300 cross 300. So this is the column size of 300 into 300. Okay, and then we change this, just change this one. Okay, take this and change this one, select 300 selected, right? Just change this size here. So let's do here 300 into here, let's do 450. Okay, this depth let's give, and then click on OK, and we'll save this as C 300 into 450. Okay, and then click on OK. So first of all, we'll select this 300 to 300 column, and at the four ends of the lift we'll apply them like this, and then we'll decide the orientation later, but let's go 300 into 450 orientation and have this. So we'll have a column here, we have it here, we have it here. So this locations we have the column, will change the orientation later depending upon the alignment or etc. So you can see there are 1 2 3 4 5 6 number of columns, so we have 6 number of columns here. So in the next row, however, we have only one column which will be here. I have moved this from here to here and in here, so symmetrically we'll have one column here and one column here, and this is it. And for the next story we'll have 1 2 3, except for these two locations. In all the other locations we'll have columns in the next particular location. Okay, so this and this. Okay, and in the next location there is no column. On the end there is column at all the locations 1 2 3 4 5 and 6. Now once these columns are defined, you can change the orientation of any column if you want, depending upon the distance here. So you can see this distance is quite a large distance, so we'll keep the orientation in this way. And for this, if you want to change the orientation suppose to this way, just let me show you how to do this. Select this and also select this column, and also control select this column. So two columns are now selected. We have to change the orientation here. So in here simply we'll change the rotation angle to 90. So you can see this rotation changes here like this. Okay, and offset also will do, but we'll do after providing the beams. Okay, so let's provide the plain beam. So select the beam here, and in here just M30 grade concrete, this is selected, FE500 reinforcement, and select the alignment releases is okay. We'll do the secondary beam later. Assign analysis and design, this is okay. Assume crack, as per IS code we have to assume moment of inertia is 35%, so it will be 100 minus 35, which is 65%. Okay, so 65% will be cracked, only 35% of the section will take for the design. So this is it, and the size here we can change here, the size 250 to 500. So we'll save this as B 250 cross 500 and save it. So we'll just open this size here and look up for any secondary beams if we have any. 1 and 2. This is the secondary beam which we are having, and this is another secondary beam which we are having here. Okay, so this is the secondary beams which we are having in the case of the this plinth level. So let us do this. Double click on here and go to releases. So here you can see from this is the top view. From left one is the N1 and left is the N2. So N2 is pinned here, which will be acting as simply supported. Okay, so this will be acting as simply supported. You can do moment MZ also, moment pin MZ. This one also you can do. So this you can do. So we'll just make this for this. So escape this, click escape. For this one, this is N1 and this is N2. And double click this and go to releases. So we'll just make this N1 as pinned. Okay, and this N2 will be pinned because there is no column in N2. Double click, go to releases and make the N2 as pinned. Okay, so this is okay. And then the remaining part, just go to beam and select this beam here. We already selected, obviously. Select this, click on escape first, select this beam, and this beam has been selected. So you can in this view it will not be there. So go to structure base and then select the beam here, and then we add the beam here like this. So here we'll discuss two more important things, because one is how to deal with the intersection error. This will deal with. Okay, so this is done, and you know how you can check for the intersection error. Let's solve this first. So first of all, you go here, solver view. So in this solver view, you see where the points we have intersection. These nodes should have a common point. So select this and select this node. Just escape, click on escape, select this one and select this. See this intersection point. You can see if this intersection point is here, then obviously we'll have some problems, right? So we have to solve and we have to get this intersection points in a proper way. Okay, so just escape and then select this again. So you can see usually it comes around like this. It doesn't come. First of all, you go to the normal structure view and then you go to scene content. Scene content, you have this members. The members, right click, not right click, left members, left click, and just untick the geometry and click on OK. So this particular view, it will be easier for you to do this thing. Just select this and do this. Okay, so you have to do this in this view. Solver view can check whether everything is in line with the thing or not. So this point node I'm adding here. So you can see if you have node like this is okay, but if we have intersection, then we have to have nodes at the intersection for both the beams passing. So that you have to check. So again, let's go to the solver view, and so just to check where now there are any intersection points or not. Here we have another intersection points. This one also you have to fix. So we get back to the structure view and then select this and move this one here, and then select this and move a node from an element here. So now go back to the solver view and check here. So we are fine, looks like we are fine here. So now we can go and go to the scene content and left click and then turn on the geometry, and then structure view again, members, left click, turn on the geometry. Okay, so now this is done. So now the next solution which I'll tell is this one. So the column is of 450, okay, and the beam is of 250. So first of all, you do what is above this grid line. What is above this grid line for the beam? So it is 250 divided by 2, which comes as 125. And what is 450 divided by 2? It comes as 225. So a simple calculation, 225 minus 125, it comes as 100. So 100, I have to bring this downwards. So I'll select this particular column. Okay, first of all, let me do for one column, so just for checking. And you have this look in the left side of your screen. Here you find this option of alignment. In alignment we have measure snap level, minus measure snap level is for this direction. Okay, you have this the top and bottom, and for left and right you have minor snap. So measure step offset, first of all let's do for how much value will do 100. So if you do positive 100 it will go upwards, and negative 100 it must go downwards. You can see this goes downwards. So like this, you just select this, this. So all this you can select here, those which you want, and after selecting this you can just make this measure offset minus 100. So it will all come downwards. If you want this all of this to have in a single line, so you really select all this here like this, and we'll move this upwards, so it will be plus 100. So like this you can move the bring the beam this side. So now another thing, select this column, control and select this column, and control and select this column. So another calculation we have to do. So we know already beam center is 125. In this direction, this is this beam is this column you have is 300. Okay, so 300 half is 150. So again, so this in this side is 150. So 150 minus what is the half of this column? This is 125. So 150 minus 125 is 25 mm. So 25 mm we want to move in this to the left side of our screen, so it will be negative. So here select this and go to alignment, and since you're moving from left, so it will be minus left level. So and since you're moving left, it will be negative, so negative 25. Enter. You can see this moves along the center. Similarly select this column, and then we'll select this column. So by the way, it is not compulsory for columns to stay inside the building. It can stay outside the building as well, but depending on project preference, if you want to make it inside, that's I am showing you. So this will be, now this will be in the positive direction, so it will be positive 25. Enter. So like this we can do. Here let's check the structure 3D, and let's check in the structure 3D, proper 3D way, and see this is done. So now let's go to the, you don't need to go to the front page, just select this and select here the supports, 22 items. Make everything as fixed, because if you don't make the supports as fixed, then we will not get any moment for the design of the footing. Okay, and the footing result might not be correct. That's why we are considering fixed supports. Okay. So now let's go and do the first floor. So the first floor, and except the terrace floor, everything will be similar. So we'll go to construction levels first, and in this 2 I'll make this source as 1. For 3 also make this source as 1. 4 make this source as 1. 5 make this source as 1, and 6 also make this source as 1. Only the terrace floor it will be different. So if I model now at one level, it will be copied to the other levels as well. So go to the structure and go to levels here and go to this one, and before that you want to insert some slabs here. So slab in this area, just add, and if you want to add a beam here in this portion also, you can do. After the staircase ends in this portion, you can also do a beam adding here, but that is not compulsory. Okay, this you can keep it like this. Okay, so go to the structure 1, and in this structure 1 we'll draw the beams here, or else what you can do, you can just copy this for now and then do the thing. Okay, but I'll make this beam here. So first of all, take my beam here, and yeah, this we have balcony, so we'll create some balcony grids as well first. So go parallel quick, and this is 3 feet, so this is 0.91. So press F2, 0.91 to the left, enter, and similarly we have this F2, 0.91 to this portion, enter. Okay, now first of all make the primary beams as usual. Okay, here we'll increase the size since this is still higher loads. Okay, so it will be, and also some torsion also it will be there, so it will be 300 for us, and into, and this one will be 600. Okay, so just you can save this particular beam here, B 300 cross 600. Okay, click on OK. Take this 300 to 600, select this, and then do this. Make sure we don't give the primary beams first as usual. Okay, secondary beams also we have to do here, from this to this, this to this, and in this case I think we can go like this also. Okay, this is not required I think, so go skip that, and we'll do the secondary beams, assign the secondary beams later here. So first of all, select this, double click, releases, and in this releases end one will be pinned, and in this double click, releases and two will be pinned. Okay, so this is done. Now let's look out for the errors. So first of all, I'll go here to the scene content, and in the scene content I'll click on this members, and I'll take the geometry and click on OK. And then similarly the intersection problems, I'll solve this, move this to this, and move this one point to this. Similarly I'll have this problem in this portion as well, since this is similar floor, and move this to this, and we shouldn't have the problem anymore. And we will just move this grid little bit. Okay, just escape here for now, and click on scene content and members, and left click, and then turn on the geometry. So again, scene content, members, turn on the geometry once again. Okay, now it's done. Okay, so for this one, not this one, this one, we'll increase this little bit. We'll increase this also little bit, since it will have the balcony portion here. Okay, and this one also will increase this a little bit, and the balcony will start from here. It will be from, let's check the balcony portion in the plan. So it will be from this, yeah, this is there was a secondary beam here after 10 feet, so we haven't given that, so we can it is actually 10 feet 8 inch, like this one. So we can still give that. Okay, so 10 feet 8 inches means 10.67 divided by 3.28 is equals to 3.25. okay, 3.25. so let's skip it here quickly. Here parallel quick, and take this from here, and F2, 3.25, move it upwards and enter. Okay, so we can copy, in theory you can copy this one. Just click on escape first, copy this these two beams from, go to edit and go to copy, and then select this point, and then actually select, there is no node here, so better if there is a node, it will be better to copy. So we'll have the solution to that. Okay, select this and then make a node to this grid line. Let me try using the scene content option, geometry. Okay, so let me see if it snaps to the node here. No, it doesn't snap to the node, so we have to find an alternate solution to this. Okay, so an alternate solution is needed. So what is the alternate solution which you can offer? Let us delete those. These let us delete this, and also delete this one. And then first of all, we can copy this one and this one, copy it from this point to this point. So now it will be accurately copied, and now we can go to, now we can actually, this will be actually fully, both will be fully pinned. So double click, and then releases, and one pin and two also pinned. here, okay, and this one also. Double click here, releases, and 2 is already pinned, and 1 is also will also be pinned in this case, okay. And here we go to beam, and P 300 600, just select this and select this, and here we can just make sure the intersection problem is not there, okay. This we want to add a node here as well. This is okay, and here also we want to keep a node here as well, and intersection problem shouldn't be there. Let's validate the model just to check. Also, there is no validation error, means the intersection problem is not there. Now we'll move this grid little bit upwards, and we'll move this grid just to give the balcony portion. This balcony is similar floor almost, so just to give this balcony here, from here, and from here, and this balcony is from here to here. So we are taking the beams here. Take the beam and B 300 600, select these points, double click and select this point. It starts from here and stands, okay. This I haven't added, my bad. Just select this and extend this like this. Select the beam here and take this point and double click on this point. Take the beam here, double click, left click, double click. So let's complete this one first. So once this is done, now important things need to be done. Select this, so it is starting from left to right, so left end will be cantilever end. So I can do multiple also, I think. Select this, and select this. So left one will be cantilever end. So here go to releases here. So end one will be cantilever end one. Okay, done. And then select this one. This will be end two will be cantilever. So because it is at the right. All these four. Go to releases in here and select end two. End two will be cantilever. Done. Now after doing that, we have to join these beams. So go to edit, click on join. So after click on join, select this and okay, click on escape first. So go to join and select this, and then select this beam, and then again select this and select this beam, select this and select this beam, select this and select this beam. Let's see the effects here. This beam is full now, this beam is full joined, this beam is joined, and this beam is joined. So let's do for the right side here. Click on join here. This and this, this and this. So let's check the effects here. So it is joined or not. This is joined, this is joined, and this is joined. Okay. So now let's apply the slabs here. Model slab on beams, or not slab on beams. Click on apply, and this normal slab on beams just apply here like this, except the staircase portion. Okay, then in this portion we'll apply the flat slabs, because otherwise we cannot apply the slabs in this portion unless we keep a beam in the vertical direction here like this. Validate the model. So now to solve this error, just simply select this one. You have to do this one individually and double click here. So this will be, since this is a single beam now, go to releases, go to span one and make this cantilever end as okay. So double click here and go to releases, go to span one and make this as cantilever end and click on OK. Select this, double click, go to releases, same thing we'll do. Okay, so here for the last end also, here double click here for the last span we'll do now cantilever end. Okay, so we had not done the last end, I think that's why it is showing. One end we had done and one end we had not done, so that's why the error is showing. So if you provide the cantilever end, this is already provided, and this is should already be provided. Okay, so now validate. Now we don't have any validation error. So the model now doesn't have any validation error here. So what we'll do, we'll simply copy this flow to the next floor. Okay, so go to this 7 and make this source as 1, but we'll make this unique later. Only for the last floor we'll make this as unique. Okay, now for validate, validation is okay. Now we'll add another headroom level here, insert above, and the spacing will keep as 2.4 meter, and this will be our headroom level. So we'll click this OS OK, and this lift level and this headroom level can be different as well. Okay, so let's keep the lift level as 2.4 meter and headroom level as 2.6 meter. Okay, so first of all, let's keep the lift here 1, 2, 3 and 4. So for the this lift and lift beams, and top will keep the section, this section is okay, and the top level will keep the structure 8. Okay, structure 8, this has been given, and let's go to structure 8 properties. Structure 8, take some beams. This is okay. Apply a slab. Okay, you can not choose to apply or not apply a slab if there is headroom and all other things. So again, go to structure. So we go to construction levels, and from structure 7, it was make another insert above, and Control Z. 7.1, just delete the 7.1 here, delete. Okay, this is okay. Above this, insert above here. The spacing from this will be 0.6. This is enough, and then click on OK. So for this, we'll have the staircase portion. So it's not compulsory to add the beams lift to the last level. You can choose or not choose to do so. Structure 9. Now I'll go to structure 9 here. Beams. Oh, I've added the wrong columns, I think. Control Z. Wrong columns have been added on this. Control deselect this one and select this one. Now I think we have the right columns here, 4 columns. Top level, structure 9. Go to structure 9, beam, slab on beam, like this, slab. So staircase, lift portion slab you can have or not have, you cannot have, depending upon. You can have the thinner slab as well. Just have this thickness here. Reduce the 200 mm is not required here. Only 125 mm is sufficient. Okay, so this is the structure 3D, and this is the portion here. Or you can have one particular roof for the both of these portions as well, so no problem. So this is the structure which is ready. Now let's apply the loads here and finish our task. So first of all, go to structure base here, and first of all check the construction levels and make this as sure it is unique in the top floors, terrace floor and above. So here we'll apply the dead load first. So go to the structure base, there is a plinth level. Application of the dead load comes into account. Now click on the load here, full UDL. So the calculation already I've shown. Again I'm showing here calculator. Thickness of all the walls will take as 125 mm in this case, but I think there is the outer and expected this has been covered, so we'll go for this. So 250 mm walls in the outer, 250 into height is 3 meters into unit is 20, it comes as 15, and let's take 7.5 for the inner walls. So for the outer walls, wherever it is, apply 15 here. So we'll apply it like this. Again I think this will be applied only in the staircase portion, because it will be a stilt floor and there will be no parking and nothing else. Okay, and we will not allow any floor finish load as well since it's the stilt floor. So let's go to the next floor now. So for applying dead load, make sure here the dead load is selected, and then you go to load, and click full UDL. As we have selected, shown how to calculate this, 15 will be applied on these outer walls here. So starting from here, we apply this 1, 2, 3, 4, 5, 6, 7, and 8, 9, 10, 11, 12, 13, 14. Here on the lift also place the 10-inch wall load, and this staircase portion also 10-inch wall load, and the remaining portions will put half of this particular load. Okay, I think I placed 5 by mistake, so I have to correct that. So to correct that, so that's why I made this mistake. It is good. I can show you how to correct it now. So if I select this like this, Ctrl plus A, like this, and then select this load items. Now I can change this to 50. Okay, so I can make the correction here, and the remaining places I'll do here. Let's go to steam content and turn off the slab items, and remaining cases I'll do full UDL, and but it will be 7.5, the half for the other walls here. Okay, for this wall, so let me just apply this now and just see what is the image which is there in our architectural plan. So here we have the 10-inch wall, it is there, then only roof door is there, so it will be 10-inch walls on these sides as well. So just rotate it, right click of your mouse, select this load, and let's see, control, if you can control select these two loads, and also rotate and control select this one, and control select this one. Just change the value to 15. Done. So here this portion is done, and we'll turn on the slab items now and put on a level load as floor finish load of 1 kN per meter square. Let's put this. Wow, finished. And after this we'll go and put the imposed load here, and imposed load will put a full level load of 2 kN per meter square for the residential building. Okay, and now we'll check in the structure 3D. You can see, since this floor is similar to all the other floors except the terrace, so dead load is applied and also live load is applied. Okay, so we only have to do now, let's validate also to check validation is okay. Now we only have to do for the terrace floor. So let's go jump to the terrace floor. So terrace floor is, go to the structure, go to levels, structure 7 is the terrace floor, and then just turn on the dead load. And you can, if you want, turn in scene content, go and turn off the slab items first, take the level load of now, and on the staircase what will be the load here. So you can change this value also. Let me just give the same value, 15, on the staircase and the lift, full UDL. Here select this as 15, and 1, 2, 3, 4, 5, 6, 7 and 8. This is done. And for this parapet wall load, let's calculate here. Let's take 10-inch wall, 0.25 into 20 into 0.75. let's take the height of the wall, 3.75. let's apply 4 here for the parapet wall, 4. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, now let's turn on the slab items here, and here in dead load, in the form of level load, we'll apply a level load of 1 for the normal floor finish and 1 for the waterproofing load, so 2, and also we'll apply an imposed load of level load of 2. Okay, go to structure 3D. Here this is the imposed load, this is the dead load here which is acting, so it's perfect. Now we'll go to the load, and we'll go to the seismic wizard, and then we'll apply the seismic load here. Ignore seismic below the structure base here, and zone will be zone 5 will take, and obviously import factor will be 1 here. If this is more than 200 occupancy, then it will be 1, 1.2, and if it is an important building, it is hospital, etc., any public building, then it will be 1.5. okay, next. And okay, it may be a residential building also, more than also. So depending on that, you do this. Next, and then we'll click on next here, and here we'll select the RC moment resisting frames here, and we'll tell the program to calculate the fundamental time period. And here moment frame system, we'll use the SMRF here, special moment resisting frame, and this is seismic weight definition. We'll add, you can see live load is 2, so 0.25% taken. If it was more than 3, then 50% will be taken. Next, and then finish, and then create some load combinations for the earthquake load, and also create the overall load combinations as per our IS code. So once this is done, we validate the model first, and after validating, we click on design and design on static. So you can see this is the result. So 2 columns have failed. I think the columns of the staircase have failed. Okay, so we will select those columns, control, and control, and make them, increase the size. Here it was this whole column size was 300 into 450, and we will change the size of this particular column here, and maybe 350 here. We'll give, click on OK, and right click, and design selection static. Let's check. Now it is passing. Okay, we'll check in the review. You can go to the rate relation ratio and you can check. You can see everything is passing here. So now let's check the individual design for a particular column here. Right click and check member static. You see 625, 616, 1025. So this is pretty much some column design. Let's see, check a beam design here. Right click, check member static. Top 316, bottom 312. Pretty much good design here. Let's check another beam, this beam middle wall. Let's select, right click and check member static. So 312, 312, next span 316, 312, next span is 316, 312. So next span is 316, 312, and next span is 312, 312. So it is pretty much good. It is coming the beam design. So you can see the beam design, and this design is done. If you want to design the foundation also, we can do this. So let's put the foundation here, and let's put the pad base column. So in here we'll go here and just enter the SBC here. Let's go for SBC of 175. You can enter as per the soil test report here, and then simply assign the pad base to here, and then click on design pad bases. Obviously there will be warning of development length. You have to ignore that if you are designing by IS code. They have not yet fixed that particular bug. Okay, yeah, you can see even 2 footing have 2 footing has failed. Some footings have failed since this is a huge structure. So you have to give this particular area as combined footing, or what we have to do, we have to delete this. First of all, select this and click on delete, and only now select the pad base, and the remaining ones you don't want to delete. Pad base you delete. Okay, pad base have been deleted. Now we will go for here we'll go for the bottommost part. What is the bottommost part? Which is they go to so we'll validate the model, update the validation. Okay, then we'll go to the bottommost levels, which is go to structure, go to levels, and go to the bottommost level. So if you're planning to design go to model and use some construction lines parallel quick, and from here we go here at least 500. So F2 0.5, enter. And from here also, from this side also, we go at least F2 0.5, enter. And from this side also we go F2 0.5, enter. And from this side also we go F2 0.5, enter. And now make sure that we can click on this. So this one, make sure we increase this particular part to match this. Okay, because when you are creating this, going to the foundation and clicking on area, we can usually just click on the grids here. Okay, so you can select this like this. Okay, if you double click on here, that is also okay. Just double click, this is fine. Okay, this is fine. And in here, overall depth, give me this overall depth 300. Obviously the grade of concrete will be more, M30 at least minimum. And allowable bearing capacity 175 was the bearing capacity which we had taken, so this was 175. And structure 3D, so go to design and then design all static. So after this design all static is complete, then just right click here. Okay, and then you can click on design slabs. So what happens is, if once you assign the mat, you see this mat is passing. So some beams are, slab is failing, but this is not our objective. Our objective is this one. This mat is passing here, and then you right click here and check slabs now, and you can check the reinforcement of the mat footing here, or right click and here we have report for member. We can have, so you can have the report for this particular member. See the bottom layer 16300, 16300, 16300 spacing, and the pressure also, it is passing in the pressure. So you can see the reinforcement design of the mat footing. So once you design the mat footing, first of all apply the mat footing, then design all static for the entire structure, and after that you can design slabs to design the mat footing, and in the report you will get the mat footing design. So that's how you get the drawing for the mat footing design. So you've done, friends, you've done this G+6 building design using the mat foundation. If you like our effort, make sure you like the video, and if you have any doubts, you can ask in the comment section. Thank you.